morning, class.
Good morning, Miss Nolen.
Okay, great.
Miss Nolen, how are you doing?
I'm doing good. How are you?
I'm good.
Great. So how was everyone's weekend? Good, I hope.
Good.
Okay. So let's get started. We're going to go over today's objective. So today's objective says scholars, you guys, will be able to list and recognize different types of adaptations that assist in an organism's survival. Furthermore, you all will be able to analyze data related to survival under certain conditions. So before we get started with our whole lesson for today, let's start off with bell work. So everyone has sheets of paper out. Good, you're prepared. And for today's bell work, we want to construct a thinking map. So if we can remember, at the first beginning of the school year, we talked about how thinking maps help us think critically and put our ideas on paper. So for this thinking map in the middle, I want you all to put your favorite animal and then put characteristics that you think help them survive in their natural habitat. So I want you all to get started, and while you're doing your bell work, I'm going to do mine. I'm going to choose a new animal and then we're going to get started. Okay, so for my animal, I chose an elephant. And from this list, or from my thinking map, I'm going to go over only 2 examples. So I went over I chose the trunk and the size of an elephant. So the trunk of an elephant helps it to bring water into his mouth and suck up objects and also bring them to his mouth so he's able to eat. So many times in a circus or something, we've seen a trick where an elephant, snuffs up a peanut with his nostrils and then he feeds it to himself. And then for their size, although elephants are silent creatures and they're herbivores, we notice that they're really big. So some smaller creatures may get out of their way or just be, afraid of them because of their size. So their size is something that helps them adapt to their environment and helps them survive. So I've given my example, but I want to hear from you guys and what you came up with for bell work. So let's not all speak at once, but someone. Okay, Brandon.
Okay, so my animal I chose was a cheetah.
Okay, a cheetah.
Okay, so cheetahs live on the savannah, and so they hunt wildebeest, I believe those animals are called. And cheetahs are very fast. They have very long legs and they run very fast, so their speed helps them hunt.
Great. So cheetahs was Brandon's example, and he mentioned like how fast they move and how fast they go. So being able to run fast towards your prey, which he noted as wildebeest, is something that helps these animals survive in their natural habitat or in other habitats. It helps them adapt. So with that being said, and with us going with bell work, we're going to move on to our 3 types of adaptation. And so our 3 types of adaptation are as follows. First, we have structural, behavioral, and physiological adaptations. So we're going to go with the first one. Structural adaptations are adaptations that the animal has in the physical. So for example, a bird has a bill, and that is something that is a part of their physical structure and helps them adapt. So it's a part of their outside being, something that we can see with the naked eye. So I use the example of a bird having a bill. So I want you all to give me an example of a structural adaptation, something that's on the outside that helps an animal survive in their habitat. Ebony?
Well, a bear has claws, and claws can be used by the bear to defend itself against other predators.
Exactly. So she noted that claws are one of the structural adaptations. There's something that's on the outside that helps the bear. Brandon, did you have an example?
I chose a turtle.
Okay.
Shells.
Yes, great example. So a turtle does have a shell, and that is a part of the structural adaptation of a turtle. Now we're going to move on to our second type of adaptation. Our second type of adaptation is behavioral adaptations. And behavioral adaptations are things that animals do in order to help them adapt. So, for example, in the winter months, a bear hibernates until they're able to get up and go and feed themselves properly again. So they hibernate and they sleep for a long period of time in order to adapt to their environment in the winter months. So I want you all to give me an example of a behavioral adaptation for an animal or another organism. Yes?
I know roly-polies, like when they feel threatened, they kind of like roll up and like they survive in like cold and like wet, dark places because they have a dark shell. Okay,
so Carry-On mentioned two different types of adaptation in one. So his first adaptation was a behavioral adaptation, and he talked about that roly-poly, something that they do is roll up in a ball when it comes down to protecting themselves. And he also mentioned that because of their dark shell on the outside of their body, which is a structural adaptation, they're able to survive in cold and dark places. So before we move to the third type of adaptation, which is physiological adaptation, I want to describe a term. I want to introduce a new term, and the term is homeostasis. So I want you all to write this term down, and then we're going to move forward with our third type of adaptation. So homeostasis. Homeostasis relates closely to our third adaptation. Okay, great. So homeostasis is our body's or an organism's body way of keeping balance inside of the body of the organism. So with that being said, we always are trying to keep balance. We're trying to keep a certain temperature in the body. We're trying to keep our blood pressure at a certain level in the body, just everything so we're fully functioning. We drink enough water so we're not dehydrated throughout the day, just to keep balance so we're not feeling sick or abnormal. So with physiological adaptation, this is something that our body does in the inside to an external stimulus. So with physiological adaptation, our body does something, I'm going to repeat it, something on the inside that helps us survive on the outside. So if something is attacking us or making us feel different away from our homeostatic state, then our physiological adaptation kicks in. So I'm going to take this one upon myself and kind of describe it for you all. So suppose it is really cold outside. Last week it was about 4 degrees here. And some of you may have experienced shivering in your face, in your hand. You were just really cold. So that shivering is a physiological adaptation. Your body, your brain tells your body to shiver in order to maintain warmth against the cold that is attacking your body from the outside. So, does everybody understand the 3 types of adaptation, or are there any questions about it? Okay, great. So we're going to move on to doing data in order to put these 3 types of adaptation into effect. So over here we have some data, and this data mimics some data that was done in 1896 that led into Darwin's study of natural selection and how other populations continue to go on. Yes?
Oh, so Darwin, is this Charles Darwin that studied finches in the Galapagos Islands?
It is Charles Darwin who studied finches in the Galapagos Islands. So this is exactly the same Darwin that we studied a couple weeks ago, and this study helped with to further his studies in natural selection. So for our study, we have 2 different moths. We have black moths and red moths. And you can notice just from the beginning of this that someone is increasing and someone is decreasing in numbers. That's coming from our y-axis, and our months are on our x-axis. So I want you all to look at this graph for a second, and with your group members, just kind of describe what you think is going on here based on our 3 types of adaptation that we talked about.
Well, I noticed that in the I see the trees, the red moss, and the rest during the months. Maybe because I guess it might because they can adapt and function in the compared to the black moss, they don't.
Maybe their food sources vary from the season.
It's around the spring, and
I don't know.
there's a lot of colors out in the grass and stuff. But
Maybe it just happens. It does happen that way.
So I've heard some good dialogue. We're gonna bring it back in and wrap it up. And so I heard something about like maybe their food source is not plenteous during certain months, and that is why one of them is decreasing and the other is increasing. So we're gonna talk about what is actually going on in this graph. So right now we have a graph and we're paying attention to the external environment around these moths. So these moths live close by a village and they stay in the forest. And in this in the winter months in the village, there are people who smoke their chimneys and they become temporarily stained. So the trunks of the trees in the forest become temporarily stained so that they match the color of the black moths. And then in the warmer months when people aren't smoking their chimneys, the trees go back to their original color that is reddish brown that relates to the color of the red moss or the reddish brown moss. So we can see that these moths in different times of the year, because of their surrounding circumstances, are able to camouflage, which is something that is behavioral that they do in order to blend in with the trees that they live on. So with that being said, does anyone want to go into more depth or just talk about what is going on here, or what they, what they came up with, or another example of what this graph could be towards? Mia?
Okay, so in our group, we was talking pretty much what you were saying, like for the red moss, especially during the warmer months, since the trunks go back to their reddish colors and they're able to like blend in better. But I was saying like I guess whenever they increase, both the black and the red moss, they're able to thrive better since they can adapt to those weather climates.
Exactly. So them being able to thrive better is directly related to their adaptation. And as you can see, these moths never go down to exactly 0. Like they go down to 100 moths in the forest, or go up to 700 moths in the forest. But there's always some moths who are able to adapt better to lead up to them surviving in the next season or the next couple of months. So with this being said, we have reviewed our data and we have also went over our 3 types of adaptation along with our new scientific vocabulary word, homeostasis. And so we're going to prepare to go into our science lab. Is everyone ready for science lab?
Yeah!
Great. Okay, so for science lab today, we're actually dealing with real live animals. So we're going to deal with lizards.
Lizards?
Yeah. We're going to deal with lizards. And we're going to have 3 different types. We're going to have 6 different lizards, but there are 2 different groups, and there are going to be 6 total. And so we're going to have some reddish lizards, and then we're going to have some lizards that are more of a bluish tinge color. And we're going to put these lizards together and see how they adapt together, how they live apart, and we're also going to see how they deal with each other when there is light in their habitat and when there is darkness over their habitat. So how do they deal together and deal apart with light and dark? So we're going to put a lot of external stimuli on these lizards, just like we did for our physiological adaptation, and see how they relate to that. How do they adapt? Do they change colors when it gets darker just because, they're trying to blend in with the dark because they don't want to be harmed by predators? Do they play like they're asleep, or, do they bite? Is that their way of protecting themselves? But just kidding, they don't bite. But we wouldn't have you play with them if they did bite. But we're going to go outside and we're going to pack up and we're going to examine these lizards and just get to know them. So over the next couple of weeks, we can put these stimuli around them and see what they do. Yes, Brandon?
Are they slimy?
Lizards are not slimy, which is contrary to belief. They actually just feel kind of scaly. They have like a little shine to them, which makes them look slimy, but they're not slimy. So, with that being said, I want all of you to pack up your belongings so we can head outside for science lab.